Thank you, Frederica. Welcome, everyone. Good afternoon. So I have attended FOSS4G for a few times, and I'm very glad that we have this academic track and we have so many audience. Thank you. I really appreciate your participation. So I'm associate professor from IMRT University, Department of Mathematical and Geospatial Sciences. And I teach open source GIS. That's the main reason I'm coming to attend the conference, and with my two PhD students join us. And there will be more interesting talk tomorrow. So a little bit of advertisement. Tomorrow, the whole team, we will talk about students' open source GIS projects. But today, I will talk a little bit academic, like research-focused topic. But I'm trying to link to how we can use this street view imagery and open source workflow to help us understand develop urban informatics using a lot of free data. So the title is Seeing Through the Crowd's Eyes, using AR-powered urban insights from Street View Imagery. And I lead a team called GI Cell at IMRT. We have a similar logo as this FOSS4G. Right, okay. So my talk will include, first I just give a background introduction on why we using the street level imagery as a source to do analysis in contrast with a traditional top-down urban data, and the tech advantage of the rising GeoAI, especially with the capacity we can apply on big data, big geospatial data to derive urban informatics. I will touch on the very basic methods. For example, how we can use API to get the street view imagery, and what kind of techniques, GeoAI techniques, we can derive the data from street view imagery. And I will going to present 4 case studies, including how we can actually extract the infrastructure asset using street level imagery with AI, and how we can actually take advantage of street view imagery to help assess the thermal comfort in response to climate change adaptation. And another study is about how we can use street view imagery with AI to understand the street livability using streetscape analysis. And the final one, we have 2 studies looking at how human perceived urban and measured urban form, they can combine together to help to make a better decision in terms of urban design, urban planning. Okay, so I would like to acknowledge, so what I'm going to talk about today is based on the work with my collaborators, and there's a list of boring academic publications. I'm not going to read one by one, but it's an acknowledgement of all the case studies is derived with the collaboration with all my collaborators and my students. So first, so there's kind of trendy, and not sure how many of you actually using this Google Street View imagery for your research, for your projects. So it's more and more kind of available data for us to use to understand, how the street look like. So that's the reason is behind it, because the street is like the human street. The city is built for people. So the urban environments are shaped not only by the physical structures, but more importantly by how people actually they feel, they perceive, and how they experience them. And in contrast, like geospatial, we traditionally using aerial imagery, remote sensing, census data, a lot of information. They actually represent our environment or city from the top-down, perspective. So kind of lacking of the perspective on how people they really see, really experience of our urban space. So with the GeoAI capability, and there's kind of research rising in the last few years, integrating the street-level imagery with GeoAI, with big geospatial data to model urban environments, actually from the perspective of residents and the pedestrians. And all the case studies is actually from this angle to do analysis. Okay, so what are the advantages of human-centered GeoAI? So we can summarize this basically extended the conventional GeoAI, because first, it captures the pedestrian perspective. In terms of Google Street View imagery, it's captured with the car passing the street, capture the human level view of the streets look like. And in addition to Google Street View, so not sure how many of you heard about Mapillary. So there's an open source platform with a lot of street level imagery uploaded by volunteers. So this kind of imagery capture the pedestrian perspective rather than top-down data. So this kind of data actually integrate subjective human perceptions. For example, the imagery uploaded maybe with people's feeling on that. If I'm feeling happy, I take some photo, upload to some open source, right? And so that including some objective spatial metrics, which we can use for spatial analysis to support decision making. And this kind of data also providing rich insights for decision makers, for example, planners, where human experience usually is very hard to capture, usually very, very expensive to capture the subjective data with questionnaire. And this kind of data also support, the analysis for enhancing the equitable design, equitable city planning. So by highlighting how different groups experience the urban space using this kind of data. So, and by using human-centered GeoAI, we can also bridge the gap between technical spatial analytics and the information from the reality what we are living, right? To summarize, the human-centered GeoAI is necessary because cities actually is experienced from the ground, not from above. And understanding this kind of experience will lead to better designed, more livable urban environments. So the methods is we have a lot of free Street View imagery. And with Google Street View imagery, they have license. However, there are approaches or avenues. You can download the Google Street View imagery or sign a license with Google to get some Street View imagery. And the Mapillary is a platform provide free Street View imagery. I will show you in the following slide. So those imagery provide immersive ground level visual, reflecting real human experience. So with this big Street View imagery data, and we can apply AI and geospatial analysis to derive object, to segment information, or to do, perceptual level modeling. So the methods at the moment is including object detection, semantic segmentation, and semantic-based human perception. I just got some water. Okay. Okay, so using this open source street imagery and the GeoAI, so we contacted few research, and the first one I want to show you is the imagery from the Mapillary platform. So I take this screenshot from the Mapillary platform, which I put New Zealand in the middle. Yeah, so currently, so how many of you using Mapillary? Yeah, thank you. I'm not coming from Mapillary company, right? I have to make it very clear. So currently it's more than 2 billion Street View imagery being uploaded to the platform. So I just took one, final one, just outside of the building. Right, so I have 4 case studies. The last 2, street perceived and measured urban form, we use the Mapillary data. So the first one, the urban infrastructure mapping, that was done before 2018, published on 2019. So that during the time, we only have the, access to Google Street View imagery. So that one is from Google Street View imagery. And the second one, climate resilience assessment, we use Google Street View imagery as well. However, the following projects in my team, we more and more using the Mapillary Street View imagery for analysis. Okay, so this is our case study. We use the Google Street View imagery to perform object detection to derive the street sign for stop sign and the gateway sign. And I used because that's already about 6-7 years ago, published in 2019. During the time, we use very, at the very early stage of the DNA, deep neural network object detection. So using a very traditional way to label all the sign, then train the model, then assign, pass the information to other, test imagery, and we use the photogrammetry algorithm to locate each sign to get the XY coordinates for the detected traffic sign. And the accuracy is reached to 95% with the deep learning performance. So the basic steps, so we're using the deep learning neural network to train the model, and we extract the bounding box, and using photogrammetry to method to get the location. And then we perform geospatial analysis to enhance the traffic asset database for the local government, which is significantly enhanced in addition to XY location, as well as the completeness of the stop sign. So this paper currently have got a lot of citation because it was quite the early stage of the deep learning for object detection using Street View imagery. And currently, if you go to the Mapillary website, they already have the tool as an open source workflow. You can get stop sign or other gateway sign, traffic sign from their website. So already being open source tool. So the second, our research, we using the Street View imagery to understand the tree provision, the tree shade, and also use Street View imagery to calculate the one important streetscape indicator called the sky view factor. So we use the reverse projection with this 360 imagery to get the sky percentage from every 10 meters along the street. If they walk along the street, how much the sky they can see, how much greening they can perceive. So that is important indicators to understand the streetscape for the city. And that will also inform the areas, the lack of tree shade. They probably have less thermal comfort. So with the spatial analysis, we can identify the streets with less tree shade, and combined with other spatial information, we can identify the area with more people. They need more, comfort, kind of thermal comfort, active traveling along the street. So this work, the findings have been adapted by the local council to plant the trees along the street. For example, this one actually close to a school. So we identify actually using the street view imagery to calculate the street less, covered by tree, and they need to plant more trees to improve the thermal comfort to facilitate the active travel. So extended for that research, we also combined the the sky view factor and the tree shade with the network analysis use space syntax. We try to understand the distribution of the tree shade, the sky view factor, and the building distribution, how that linked to the topology of the road network, and also how visible, for example, the tree shade along the street. Then we used the space syntax analysis to calculate 3 variables that including connectivity, integration, and the visibility indicator. Then combined with the percentage of the tree, percentage of the sky, percentage of the building, we try to understand in this city, so which street, the distribution of the streetscape align with the, the social interaction, which the street is more connected to other area or more integrated with other area or more visible for the pedestrians or citizens. Okay, so the third study, we trying to go deeper to look at the social inequity of the neighborhood. So the method is using street view imagery to calculate how beautiful, how wealthy, how livable, how safety, and is the boringness and the depression. Use some pre-trained model as a perception model. So that model is being trained by MIT based on 1 million human labeled perception. And then we use the model applied for 2 study areas. One is for Los Angeles, and the perception indicators linked to other built environment information. For example, the density, diversity, the design, distance, destination, all these built environment indicators linked how people feel on the street. Then we apply the machine learning model and some spatial analysis to identify how different streets, the social inequality linked to how people feel and align with the built environment and applied to different population group in LA, the city. And then we can define, actually show the maps of different streets, the distribution of the perception of the 6 parameters. And we try to understand the relationship between the building form indicators, how that contributed to how people feel. So we use this explainable AI to try to link the relationship between the actual built information and how people feel the information, and across different population group. And similar work we applied for mapping. So for mapping, we use the same perception model, and looking at the beautiful, wealthy, livable, safety, boringness, depression applied for the streets. And then linked to, again, the built information model. The indicators from 5D actual built environment indicator, and then linked to different streets in Melbourne. So those kind of information give a very detailed, not only the physical built urban informatics, also how people feel in different areas. So I have limited time. So the methods, I am not going to too detailed. We use the pre-trained ResNet deep learning model, and we use the already 1 million human labeled information for the perceptual indicator for the 6 types. And then we applied a multi-model machine learning spatial analysis to understand the relationship. Okay, so this is the final result for the distribution for Melbourne in different areas. We can see some areas more beautiful, some areas, could be people feel depressed, some area people feel boring, and this information linked to the built environment indicators to help the decision maker or planners to improve, the livability, in the city. Right. So I just go to the conclusion. So what we learned from all the studies. So this kind of street view imagery, we highlighted this how human feel, pedestrian perspective on the city kind of livability. So this gives us more kind of intuitive information to understand the city, to provide more meaningful analysis, right? And what that means for our free open geospatial community? So we could design more, this kind of model. Currently, we don't have any open perception model available for us to use. And if we have more open trained data set we can use, now more and more people can use street view imagery from Mapillary, right? And if we can have more GeoAI tools for us to use, then more research can be done. And the government, they can use not only the physical information, also the perceptual information to understand our city, right? And probably we can build this interactive tool for public engagement and adding more information from citizens to improve the transparency. Okay, so finally, I would like to encourage everyone to contribute to Mapillary. Again, I'm not from Mapillary, but it's very easy to do. You can just download the Mapillary app. You can capture some information as an imagery, and the tool will help you to make it reliable. For example, to remove the plates number, and you can simply just upload it to Mapillary platform. So then we will have more and more this kind of open source to use, and also I encourage and call for more tools, open source tools for us to use to combine street level imagery with open GeoAI to help us to understand our city, to make our city more livable. Thank you.